Hey everybody, welcome to week 5. Let's do a quick sound check like we usually do. So, should have, whoa, I need to move my microphone. Okay, that's probably a little bit better. All right, left and right. Hey everybody. Okay, the topic for today is server architecture. And I'm just gonna rattle off a few reference files in the help documentation that might be useful. So there is one called server architecture. This is definitely worth a read, and it talks about some of the core classes that are involved in the concept of server architecture. We kind of know some of these already. We know synth and SynthDef. There's also something called group, and node is the abstract parent class of group and synth, which we never use node directly, but group and synth are sort of siblings. And the concept of buses, both audio and control buses. And we're going to also be talking about, we've seen the out unit generator, and today we're also going to talk about in. And another reference file that's useful here is called order of execution. Order of execution. This is not the kind of order of execution where SuperCollider doesn't necessarily do multiplication before addition or anything like that. It refers to the order of synthesis blocks or synthesis nodes, objects placed on the server, and when they're sharing a signal, how those samples are calculated. So this whole topic of server architecture is useful when your SuperCollider projects start to get a little bit bigger, a little bit more complex, where you have SynthDefs, which are defined to generate sound sources, and other SynthDefs, which are designed to process sound sources. So I'm going to start by breaking the server, which is something I did in class last Thursday, but I also want to do it on stream just to demonstrate some concepts here. So let's make a frequency argument default to 400 hertz, and we're going to make a sine oscillator, and we're going to make an envelope percussive, and I want to be able to, I want this envelope to be continually re-triggered. So I don't want done action 2 here, because then we just get 1 and that would be the end of it. I could put a t underscore something here and then manually redo it, but I'm actually going to put a unit generator here that periodically outputs a trigger, basically a non-positive to positive transition, and tons of oscillators would work here. Sine osc would work, LF saw would work, LF try would work, tons of stuff. So I'm just going to do, let's do LF saw. And we'll give this frequency of, I don't know, 0.5. And we're going to say out to 0. So this should all be reasonably familiar. We're going to do an amplitude argument too. Just turn it down just a tiny bit. Right, so that works. Seems like it, and right, I forgot to make this stereo, so we'll just do sig exclamation 2. Okay, so that is a lovely, whoa. Why is it? Oh, right. Yeah, because I'm in one-shot mode where I thought it would just be happening once, but it was something weird. Okay, so we'll just run this once. Let's open the node tree as well, and so we can get a visualization of what's going on the server. And we had a false start. Let's do it again. There we go. So we got this bad SynthDef. let's make a shorter release time. Right, so, and we'll make this a little bit faster. Okay, so we got a nice sound source. And the reason I'm calling this bad is because let's say we want to put some reverb on this sound. So maybe after we apply this envelope, we'll say sig equals sig plus reverb. So the input signal to reverb is the signal. We're going to set mix all the way to 1. This is basically like a fully saturated wet reverb because we're adding it to the dry over here. Room, we'll make it a big-ish room. And let's, this has a mul argument, I think. Mul, let's turn this down a little bit. I'm going to tweak these numbers so that it sounds kind of reasonable, so. I'm going to slow this down a little bit because I'm picky. And let's try changing the damp. So maybe we'll just kind of experimenting. I'm not entirely sure what these numbers do. Versus this. Sounds about the same. All right, we're going to call that good. And maybe we'll say, call this env rate. So now, you know, let's see how well we do if we make multiple synths here. So I'm gonna say freak is an exponentially chosen number between 200 and 2000, and env rate is gonna be some random number between 0.4 and 1.2. So this should all be pretty familiar. Let's turn the amplitude down a little bit too. Okay. Let's just make a bunch of these. Okay, I think reverb's not the best UGen to demonstrate this because it's not nearly as computationally expensive as some of the other ones. So I'm going to switch this to gverb. Big room, long reverb time. So let's try this. So different reverb, gverb instead of reverb. Let's make another one. And there we go. So the server has gone belly up. It's dead. I'm going to force quit if I can. Okay. So what we did is we just basically, now let's try to recover. Yeah, perfect. Okay, I got to move this up. So, give me a moment here to readjust. All right, everybody still with me? Let me make sure I didn't lose the stream by crashing the server or something. We need the help browser. Let's dock that. And okay, good. Glad you're still there. So this is sort of the wrong approach. We are putting our source sound and some fairly expensive processing in the same SynthDef. So that means every time we gotta boot the server. Okay, this is actually a pretty good detour. Some of you might have seen this at some point in your SuperCollider travels. Exception in world open UDP address already in use. This server booting failure message sometimes comes up if you have a hanging instance of scsynth that didn't close properly, like if you crashed your server or something. My go-to fix is server.kill all, and then we'll try to boot the server again, and it worked. So, right. This doesn't, in my experience, this doesn't always work. Sometimes you might need to go into your task manager and actually, close the scsynth process manually. And in some rare cases, I've found that I just kind of want to restart my computer, and that works as well. All right, so when we make, whoa, that's loud. Why is that so loud? It's loud because I don't know. Is that loud for everybody else too? Wait a minute. Okay, I think I need to, yeah, crashing the server is never really the most elegant thing to do. Because I don't think that audio is going to, right, yeah, I'm working on it. Gotta set the right output device, and I think we're still getting input from the microphone. Yeah, okay, the input's working fine. So I just need to choose my little custom output device, and let's reboot the server. All right, and that looks like it's working. Okay, back in business. I'm not gonna, definitely not gonna do that again. But every time we make one of these synths, we're creating a synthesis process that has a G verb in it. And if we make, like 2 or 3 of these, you can see that our, maybe you can see in our CPU down at the bottom, it's already up to like 3% or something. And anyway, it's just this, these G verbs, it's basically a collection of delay lines with feedback, which is what's needed to make this reverb effect. So it has to allocate a bunch of memory dynamically, and there's only a fixed amount that SuperCollider, the server, is allowed to allocate. So a really sort of sloppy fix would be to say s.options.mem size with camel case s, and if we just run this line, you see it's 8,192. This is the number of kilobytes that can be dynamically allocated on the server, which is not actually very much at all. So you can set this to some big number, like you set this to 2 to the power of 20, and then reboot the server to have this change take effect. And now s.options.mem size is a lot bigger. So we have a lot more memory headroom to make a bunch of these. But like I said, this is kind of a sloppy solution because it's just incredibly inefficient to every time you want to make a sine wave with reverb on it to make a new instance of G-verb. It just means with very few sounds active, you're going to have like your CPU at 40, 50, 60% or more, somewhere around there. This is equivalent to, in a DAW, putting a reverb on every single track. And again, if you monitor your computer's CPU usage, it's just going to be very, very inefficient. So whenever you have sound sources that you want to be processed, so a very, very common example is you have lots of sounds and you want to apply the same reverb to all of them, it makes sense to separate this code into 2 SynthDefs. And I think if we go to the order of execution, what did I type? Order of exception, execution. I think there is, it sort of gives us an example of when you might want to do this. Maybe it's server architecture. Actually, I can't remember exactly where I read it, but what you'd normally do if you want a situation like this is you'd make one reverb effect and then route all of your sound sources through that reverb. So you only have one instance of G-verb, but your signal routing sort of takes care of the signal path, and your CPU usage stays a lot lower. So let's do that. Okay, so I'm gonna copy this, and I'm gonna split this into two SynthDefs. We'll call this source, and this can all stay the same, and we're gonna do this. And what we also want to do is specify an output bus argument. We're going to default it to 0, but 0 corresponds to our lowest numbered hardware output. But this is not actually where we're going to end up sending this. So we are going to change out when we actually instantiate, create the sound. And then we need another SynthDef, which we will call reverb. And we need to, we don't need any of this freak, amp, and rate stuff necessarily. We do want to say in and out, because this effect is going to be reading this signal from somewhere and then sending the result out to the output. So we're just going to delete all this. We're going to say sig equals in.ar. So in is the counterpart to out, where instead of writing a signal to a bus, it reads a signal from a bus. And we need to provide two things: the bus index, or the number of the bus, which bus are we going to be listening to, and the number of channels. And this is, well, I guess we've taken away the exclamation point too. So right now this is a monophonic sound, I believe. Yeah, it's monophonic. So let's make it stereo. I'm going to put an exclamation point here. And now it is stereo. Okay. So we'll say 2. But I actually want to, we're not quite done. We haven't done our reverb yet. But I just want to talk about how the audio buses are sort of visualized on the server. So there's a class called server options, which is a way of accessing configurations of the audio server, like how many output channels do we have, what's the sampling rate, stuff like that. And we've already seen one of those with s.options.memsize. Right. So there's some other ones that are useful. There is num audio bus channels, which by default is 1024. Num control bus channels, which is 16,384. And we also have s.options.num output bus channels, which by default is 2, and num input bus channels, which is also 2. And that is consistent with what we see whenever we open the level meters. And let me give you just a quick visualization, maybe, of, so if we sort of imagine our audio bus channels, of which there are 1,024, the hardware outs, we have 2 of those. Hardware inputs, we have 2 of those. And then this is only 4 of 1024 audio channels. Hey, Spacetimed, how's it going? So the remaining audio buses are called private buses. I've seen this typed with 1 S in the middle and 2 S's. I'm not really sure which one I prefer. So then we just have the remaining buses. So we have 2 here. We have 2 here. And then we have 1,020, right? The remaining buses. And the total here is 1024. We can change all these, for example. Like if we say s.options num output bus channels equals H, input bus channels equals H. And we run that and reboot the server. And also relaunch the level meters. Then we have 8 of each, so now we'd have 6 more, 6 more, and then 8 here, and 8 here, and then 1024 minus 8, which is what, 1016. Let's go back to what we had. You know what? Let's keep it. It's fine. So the way the server sees these buses as the buses with indices 0 through 7 are hardware outputs, and then 8 through 15 are the inputs, and then 16 and up are the private buses. And those are just extra audio buses that we can use for writing signal and sort of sharing a signal between two synths. So all of these buses are monophonic. There's no such thing as a multi-channel bus necessarily, but we can refer to or allocate a group of them and treat them as a single bus. So in this case, we're saying this UGen is going to read from bus whatever we provide for the in argument, and it's going to start at that bus and also read the next adjacent channel, and it's going to treat that as a stereo signal. And then we're going to apply our reverb. So that would be sig equals sig plus sig 205, and scale this down by a little bit so it's not overwhelming. All right, so we've got, and we don't even need to put these in separate parenthetical blocks. I think we can just do this, and no error messages. Looks like everything worked. I'm going to try to keep most of this open as I go. So let's very simply, I will say synth.new reverb, and somewhat arbitrarily, I'm going to say in 57. We've got 1024 audio buses to choose from, and currently the lowest 16, basically indices 0 through 15, we should consider those as being spoken for, right? They're being used to connect to your hardware outputs, your sound card, but everything 16 and up to 1023 those are available. So I'm just kind of very arbitrarily picking 57, and we're gonna, oh, you know what I meant to do? We should be consistent here and also put an out here, because we bothered to declare that argument. So we're going to say out 0. The output of the reverb synth is what we actually want to listen to, and so it will get sent to bus 0, and it's a stereo signal, so we'll see it on 0 and 1. And I'm going to open the node tree. I've gotten in the habit of using the keyboard shortcut for this, which is Alt-Command-T. So let's put this here. So let's run this. And yeah, we've got our reverb synth, which is running on the server, this little white box that appeared. We don't hear anything because there's no signal being written to bus 57. And remember, this reverb is listening to bus 57 and 58 because we've told it to listen to 2 channels starting at index 57. So that's 57 and 58. So now let's say synth.new source out. Let's start with our, let's say, frequency. Maybe we'll make this a little bit interesting. Amp. Take that down a little bit. N rate. Let's do Xbrand. So some of them will be just tend to be a little bit slower on average. And then out 57. All right, so if we run this, we're going to make a new synth. It's going to be put onto the server. It's going to be doing its Synosc, NFGen, percussive blips, and it's going to write them. Because it's stereo, it's going to write the stereo signal to bus 57 and 58. And so we should hear reverb. Yeah. Let's make another one. I'm I'm gonna command period those, make our reverb again. All right, and we've got a lovely little, you know, texture of sine waves. And we can really go, we can just go nuts. We could probably make 100, 200 of these, and the server will be absolutely fine. In fact, you know what? Let's do that. Let's make them very quiet, and we're gonna say 100.do. Right. Let's make them also kind of slow. I really don't know what this is gonna sound like, but it might sound really cool. So they all start together, and then they all drift out of phase because they have different rates at which the envelope is retriggered. That was cool. Let's do that again. Let's make them very, very. That's too slow. Let's do. It's gonna be like 10 seconds for them to repeat. Let's do some random value between 0.4 and 0.42. So reverb, and here. Anyway, the point is we're still below, you know, we're still like around 5 to 10% CPU, and that's because we've only got this one reverb sitting at the end. Okay, let's go back to the, make just one of these. Now, this is a bunch of things that we're doing that are pretty sloppy. The first of which is, you know, I'm hitting command period and having to remake the reverb synth every time. I'm also doing weirdly bus 57 for some reason, and you know, like if you had a bunch of different effects reading from different buses, it's kind of, you know, you don't have to be like, wait, is 57 the delay or is that the filter or which one is that, right? So there's some ways we can clean this up quite a bit. The first thing I want to do is let's say we make this first. So we have our source writing to bus 57. So and in fact, I also want to s.scope for 1 second, and it by default shows us 8 of the lowest buses because we've said we have 8 hardware outputs. We're going to say just 2, and then we're going to go up to bus 57. Yeah. So now we're looking at bus 57 and bus 58, and it's blooping away. It's making its bloops. But right now, no process is reading from 57. So let's make our reverb process. And it doesn't work. It does not work. If we s.scope again, we can look at 57, and we've got our bloops right here. But if we look at bus 0 and 1, we have nothing. And we didn't change anything. All we did was run these two synth.new lines in the opposite order. So this is our introduction to order of execution. And it also, I'm going to segue here into the synth help file. And we've been making synths. And synth.new has 4, detach this for a second, 4 arguments that it expects. Def name, which we've been doing, right? We need to know the name of the SynthDef. And an optional array, which consists of argument value, argument value, argument value pairs. And we've done that as well. But then that's the last thing we've done. But there are 2 additional arguments called target and add action. And we've never used those so far in this class. Target and add action sort of work together to allow you to specify where on the server your new synth gets placed. Now, the default target is the default group, which is this gray box on the default server. That's our target. And then the add action is how to place the synth relative to the target. And the default add action is the symbol add to head. And head, we can think of head as the beginning or top of the target. So add to tail would put it at the bottom, like sort of below anything else that happened to be in that group. Add after puts it directly after a target. Add before puts it before, and add replace will swap it out for something that already exists on the server. And this is all pretty kind of thick and jargony. So let's see if we can maybe back up a little bit. Let's dock this up here. So let's just watch this in slow motion here. So we our default target is the default group, and the add action is add to head. So it goes to the head at the very top of the default group. And then we add this synth. And if we don't specify otherwise, the target is again the group, and it is added to the head of that default group. So this works. But if we do it in the opposite direction, not the opposite direction, the opposite order, source first, and then reverb gets added to the head, does not work. So this is order of execution. And let's see if I can find a good sort of sentence which sums this up here. If you have on the server synth 1, arrow synth 2, meaning synth 1 is outputting a signal that is being used by synth 2, all the unit generators associated with synth 1 will execute before those in synth 2 during each control cycle. So this is only relevant when you're using in.ar, and the rule is simple. If you have a synth on the server, in other words, an effect that depends on the output from another synth, the source, the effect must appear later in the chain of nodes on the server than the source. And by doing these source first and then reverb, what ends up happening is the reverb is the last thing that's added, and it's added to the head of the group, so they're in the wrong order. So reverb is processing samples on bus 57, and at that particular point in time, there's no data on 57, and then it finishes its job. And then the source writes data to 57, and then the cycle starts over, all the buses are cleared, and so these two are not successfully talking to each other. So source is at the top, effects at the bottom, just however you need to structure that. So there's a couple of ways that we can do that. One of which is to execute these in the proper order. Basically doing it like this is usually going to work. We make the reverb, and then we make the source. So reverb adds to the head, and then source adds to the head. And if we're doing these separately, and let's say we make our source first, then for the synth, we can say target S, right? The server. The server is our target, and this is going to, we can say s.default group, I think. Right, s.default group gives us group 1. That's group 1 right here. I think S would also work, because when you specify a server as a target, it just uses the default group on that server. And then we say add to tail. And that works because the add action is different. It places the reverb at a point in the node tree so that the ordering of the nodes is correct for this particular type of effect. Okay, alternatively, let's call this X. So we've actually saved this source synth in a variable called X. And so it's running, it's writing to bus 57. And now we could say something like, I'm gonna copy these actually, just so I don't have to, so I'm not constantly changing this. So all right. So we've made this synth called X, and we're gonna say the target for the reverb synth is X. And the add action should be, let's go back to our synth help file. What would make sense here is add after. At least that's one option that would work. So it says, okay, here my target is source, and I'm going to be placed right after that source. So that works as well. And now, just as a side effect here, because we've separated source and effect into two separate SynthDefs, we can say something like x.free. And this is going to stop the sound source, but it's going to leave the reverb alone so that we'll be able to hear the full 5-second reverb tail. It takes its time going away. So this is a lot nicer than having both source and effect processing in the same SynthDef, because our only option is to destroy that entire algorithm together. So it kills the source and it kills the effect. So the reverb tail will sort of just stop right where it is, and it's not nearly as nice. All right. Now, let's talk about this 57. This is really not the most elegant way to specify, how your signals and sources are going to be moving about. So let's introduce the bus class. So I'm going to make a global variable reverb bus, and I'm going to say bus.audio. So the bus class. This is our way of talking to, or sort of referring to, allocating, and managing buses. So we can say we're going to make a new bus, call it reverb bus, on the local server S, and number of channels. Well, we've been working with a stereo signal, so we're going to say 2 channels. And we're going to run this. And notice in the post window it says bus audio 16 to localhost. So this tells us it's on the local server. This tells us it's an audio bus. 2 tells us it's 2 channels. And this 16 is a result of the fact that we have 16 input and output buses combined allocated, right? 8 outputs, 8 inputs. And so the server is aware of this, and it says, okay, well, technically these are all being used, not all actively, but they've been all set aside for hardware use. And so the next available bus that I have is index 16, so I'll start there. So it sort of manages the bus indices for us. And if we were to make another bus, let's say we had, a delay effect or something. We say S2. So now what we should see is the same thing, but with an 18, because it knows, okay, we've allocated one bus. We've sort of set aside channels 16 and 17, or buses 16 and 17 for use for something. It doesn't matter what. So now I'm going to start at 18 and give you 2. And if I were to then allocate a 4-channel bus, I'm not even going to give it a name because I'm being sloppy here. So now it starts at 20 and gives us 4 channels. So if we were going to then make a monophonic bus for yet another purpose, we would expect to see this start at 24, sorry, I can't count. 20, 21, 22, 23. So those 4 channels are spoken for. Now we have 24. So you get the idea. So it'll just sort of go up and up and up until it gets to 1023, and then it'll say, I ran out of buses, and you have to make more if you want to use them. And now that we've made these junk buses that aren't really being used for anything, we can always say s.new bus allocators. Just run this line, and that resets the bus count. So it sort of forgets all of the buses you've allocated, so it starts back at 16. And we're not gonna worry about any of these. So we've made a bus called reverb bus. So we can say things like reverb bus.index. Oh, it's index 16. Num channels 2. So we can get information about this bus. So let's go back to our example here, and we're going to make our source, and we're going to say out reverb bus. We could also say dot index, to provide the actual integer, but SuperCollider is smart enough to know that if we provide a bus, it knows to take the index value from that bus. And let's run this, right? And it looks like I had a reverb synth that was sort of hanging around there, so I'm gonna just command period that just to clear everything away. So there's our source. And now if we run this, even if we add it immediately after the synth X, it's not going to work because the buses aren't the same. So we could say something like this. It's in the right order, but the buses aren't the same, so it's not working. So let's say verb.free. There it goes. And we just need to say reverb bus here. And that is all working. So this is a little bit more elegant. Let's do this and verb.free. Because now it's more human readable. We can sort of see what the output of our source sound is, the bus to the reverb effect, and our reverb synth is of course reading from that reverb bus and outputting to our lowest numbered hardware index. Everybody more or less with me so far? Any questions, comments? Everything still going okay? Okay, so another problem here is that all of these synths are called X, and I just made 5 of them, which means x.free will only free the most recent one, and the rest of them are inaccessible, or, well, not technically inaccessible, but it's really, now it's very clunky to be able to talk to these synths, so I'm just going to do command period. And this is where groups come in. Groups allow you to organize your nodes on the server to reflect how you're conceptualizing your piece. Great, glad to hear it, B. Hinks. That's good to hear. All right, so let's go ahead and make a group. I'm gonna copy this stuff, paste it down here. If you need me to scroll back up, just let me know. All right, so we've seen synths, synth.new. We know we can specify a target now and an add action, so we can arrange things so that the sources are always upstream of the effects. So let's say source group equals group.new. Aha, we have made our own group. So it's a gray box inside of this default group. And just to show you just what's going on here. So let's make a new group. And another one, and another one, and another one, and another one. And the default groups, just like synths, have a target and an add action, and they have the same defaults. So when we do group.new, by default, it's going to, the target is the default group, which is this large gray box outside of everything. And the default add action is add to head. So they're all being put above everything that's currently there, which is why we see group number 1374, 1375, 1376, 1377. So that's just we can command period, and command period wipes everything off the server, synths and groups. So we'll make a source group, and we will say fx group equals group. A couple of ways to do this. We can specify the target, source group, add after, right? So then there it goes. Now the numbering is different. 1382 at the top, 1383 below. So we've now made 2 groups. And the idea is that we can just dump our source synths into this top group and dump our effects, or our reverb synth, our singular reverb synth, into this bottom group. And then the order of execution is, you know, something we don't have to think about really, because we've made these groups. So you know, and that sort of guarantees, assuming we put the synths in the correct groups, that the order will always be correct. So I'm not going to bother giving these synths variable names. But what I am going to say here is, so we have our SynthDef name, our array of argument value pairs, comma, a target. The target is going to be source group. Right? So it goes here. And we can make more. We can make as many as we want, and they're all going there. If we didn't specify a target, then take 5-10 seconds and imagine where, if I make another source here, where is it going to show up if I don't specify a target or add action? Where on this little visualization here is that going to it's going to show up? The default target is the default group, and the add action is add to head. So try to imagine where it's going to show up, and there it is. At the head of the default group. Now, the default group already contained two things, these two groups, and those groups contain some other things. But so this goes to the head of the default group. And that's not really, I mean, it's fine. It's still going to be upstream of our effect synth, but this is just to really reinforce the concept of targets and add actions and where things end up. So I'm going to command period, I guess. So we'll say run these two lines again. So we have our source group, which is a new group, and our effect group, which is a group whose target is the source group, and it's right after it. And now we can place source group, sorry, not source synth. And we'll do the same with our reverb synth. So our target now is going to be FX group. Sorry, that's not how I spelled it. I gotta really pick one, underscore or camel case. All right, so we're making a synth. It's called verb. It's using the reverb SynthDef. It's got its input and output. It's going to the FX group. And we don't need to specify an add action because it's going to be the only thing in that group. So we don't need to put it at the head or tail of the group or before or after anything. We just need to make sure that it goes in the group, and it will, because we've specified FX group as the target. And now placing these synths in the source group, there they go. Right. And they don't have names. You know, so it's not, I can't really refer to individual synths if I want to set their parameters or something, but the group in which they live does have a name. And so we can send a lot of the same messages to groups that we can to synths. So I'm just going to say .free all. And this will tell the group, send a free message to everything that you contain. So notice the group is still there, so we can just run more of these. And when we say free all, the group remains, but it sends a free message to every node inside of it. Now, if we say free, well, that's going to free the group itself. Source group.free, and watch that top group here. Oop, there it goes. And now, I think this is not going to work anymore. Right, this doesn't work. It says group not found. Because we have freed the source group, this is not a valid target anymore. We could just as easily say, we could say the target is now the effects group, but the add action is going to be add before. Right? So that works too. But they're not in a group, so we can't easily talk to them anymore. The synths themselves don't have names, and the group, we do have the default group, but if we say s.defaultGroup.free all, yeah, it'll free this and this and this, but it'll also free this effects group. So this is, you know, kind of what happens when we do command period. We're saying just wipe everything off the server and remake the default group. So that's groups and add actions. So this is going to be the focus of the next homework assignment, where I'll give you some sort of processing effect, and you know, you'll need to basically manage the order of nodes as they go onto the server, so that the buses are in agreement. You know, the synths that are sharing data are sharing buses, and the order of execution is correct with sources at the top and effects down below. I also want to just draw your attention to this picture that is in this reference file. So this is the order of execution help file. And it gives us this little diagram, a sort of visualization of the server. And I think what's supposed to be communicated here is that you have these synth objects basically floating around on the server. You know, they might be in various places, but these horizontal lines represent buses. And so this synth, for example, is writing a signal to that bus, and this synth is reading that reading from that bus. And if you want these two synths to be able to talk to each other, then the source synths have to be earlier. This sort of the time of the processing. As the server processes block by block, sample by sample, it goes kind of. This is like left to right, so it's kind of like rotating this thing. Sort of. I guess the other way, right? 90 degrees to the left. So this synth needs to compute its sample values first, and then as long as this one is downstream, it can read those just fine. But if these are in the wrong order, if this one is sort of writing to the bus, later, if it's later in the node tree, then they can't talk to each other. The reading process happens first, and then the writing process, and that's no good. And the data is not successfully, split that way. So there's some other stuff going on here, but basically these two synths is sort of the key way to look at it. Real quick, I just want to emphasize that it is possible to have multiple outs. So I'm gonna sort of do this a little bit quick. We got 10 minutes, so let's say I'm gonna make out.ar. We'll call this reverb out and delay out. And we'll also make speaker out. Let's see if I can do this quickly, just as like a sort of further study piece. So reverb out, I'm just going to initialize all of these to 0, with the understanding that when I actually call the synth.new, I'm not gonna make these all 0. All right, so I have 3 discrete outputs. The signal is sort of branching out in 3 directions. And I'm gonna make this. Let's do sig. We're just gonna do a fully wet signal here. Okay, so that's our reverb, and I'm also gonna make a delay. So we're going to read in from a stereo bus. And we're going to say sig equals comb n. So comb is a delay with feedback, basically. So we can specify the initial delay time, or sort of the maximum delay time. We'll say 1 second. And the delay will be 0.32. And the decay time, how long it's going to take to decay to minus 60 decibels, we'll say 10 seconds. And then we'll multiply this by 0.5, so it's not maximum amplitude. And then out.ar, out sig. So hopefully, good, that looks good. And then we're going to make 2 buses. We'll say, first we're going to say s.new bus allocated. New bus allocators to sort of reset the bus count. And we'll say reverb bus equals bus.audio S2, 2-channel bus. And we'll say delay bus, bus.audio S2. Okay, so we've got 2 stereo buses that are at the ready. Let's also make some groups. We're going to say source group. And we're going to say delay group will be, we could say source group. I want to show you an alternative here. No. Reading from and writing from this, reading from and writing to the same bus does not mean feedback. It's basically plugging one thing into the other. We're sort of making a chain of events, or a chain of nodes. So, process A is writing to bus X, and process B is reading from bus X, and then the signal just goes downstream, basically. But I guess if I'm not sure. I've never actually run into feedback if something is accidentally reading to and writing from like its own bus. I guess theoretically you could make a feedback situation there, but I think because things are calculated block by block, it's got to be possible. But I've just never. I think you have to really, really do it on purpose. So you basically, it's really unlikely you're going to hit some sort of horrible feedback situation. So we could say add after, There's an alternative. This would work just fine. We've been doing this, but you can also use the method after. So group.after source group. And you can actually do this with synths too. You can say synth, instead of synth.new, synth.after, and you first provide the target, and then you do the SynthDef name, and you can look it up in the help file. So we're gonna say delay, and this needs to be called reverb group. We need to give these things different names. So this should make 3 groups on the server, and it does. So this is where we'll put our sources, delay, and reverb. And then we're gonna let's make our synths. So we're gonna say reverb in reverb bus out 0 target reverb group. So there's that. And we'll also make delay bus, delay group. So there goes that. And then finally, we should be able to make our source sound. So it doesn't have an input. It's generating a signal from, a sine wave table and putting an envelope on it. And then we'll say reverb out, reverb bus. Let's actually make this a little bit, let's do multi-line things. It's a little bit easier to read. Delay out, make sure I'm naming this. Delay out and speaker out. This is like our direct signal. This is just going to go to 0. All right, and let's see if I have done this correctly. We also got to say source group. All right, so when I run this, we should see a little box show up here, and we should hear a very clear delay, sort of like approximately 3 delays per second for 10 seconds, and we should also hear reverb. All right, fingers crossed. Yeah, that is working. Cool. Let's get rid of the source. I just want to enjoy that 10-second fade a little bit longer, so we're going to say, what was it called? Env rate. The decay time is 10 seconds, so we could say 0.1, so that every 10 seconds it happens. So let's make it a little bit faster than that. And we'll say freak expand, just so we have a little variation here. So we'll make one of these. Right, so you can hear, right now these effects are in parallel. They're not in series. It looks like they're in series because we have delay and then reverb. But we have configured this SynthDefs to basically send out to 3 different locations in parallel. So the envelope signal is going to our reverb effect, and that sort of the initial blip, every time the envelope resets, it gets reverb on it. But that blip is also going to this delay line, and the delay is not going to the reverb. So if you listen really carefully, you'll hear an initial sort of 5-second reverb decay. Let's free all these again. And you should hear, right, so you'll hear the reverb decay, but then the delay without reverb will be continuing. So the delay signal is very dry. Now you could put these in series so that it goes source, delay, and then delay into reverb. And the way you do this is you would have the delay synth reading from the delay bus, but going out to the reverb bus. I think we can just do this actually. And then the reverb bus reading from there. And then we wouldn't need this line here because we're going to put these in series instead of in parallel. So I think that should work. So just doing that, doing this, making our 3 groups, and putting these where they go. And now we don't have this anymore. We're just going straight to the delay. And then the delay is going to the reverb. Let's see if this works. Yeah, so, and we still have our speaker out. So the first thing we hear is a big, dry, plain old sine wave. And that goes to the delay, and right, so it actually delays it by 0.32 seconds, and then that's the first time. So 0.32 seconds later, it comes out of the delay and goes into the reverb. Okay, it's noon. This is where we're really getting into the weeds of SuperCollider and the sort of precise nature of how the server is designed and engineered, and how you're supposed to conceptualize more complex networks of synthesis algorithms and how sounds sort of talk to each other and pass data back and forth. So I have a tutorial on my YouTube channel, which is tutorial 7 in my tutorial playlist, server architecture. It's a lot of the same stuff here, but it's like all the tutorials, it's more condensed, less improvisatory, and it's a lot of the same information. Just when you have a synthesis, what you're envisioning in terms of crafting sound involves source sounds and processing effects, and how to sort of organize all those things, make sure you've got your buses talking to each other, or synths using buses harmoniously, and also making sure things are in the right order. So yeah, we're going to focus on this on Thursday, and it's good stuff to know, because it helps you circumvent a lot of potential problems as you start to grow your synthesis tree, as you start to do more and more complex projects. So I'll stick around for a few minutes if anyone's got any questions. Any comments, anything like that? Let's see. I think if we do this, then we're actually incorporating the dry signal into the delay. So we're actually taking whatever comes in and summing it with the delayed output. So this should fix our the fact that we hear a big dry signal at first, and then the delayed reverb. Yeah. So we get an initial dry signal that goes to the speakers, but it's also simultaneously going to the delay bus, which is being read by this delay synth, and it's taking the dry signal and adding it to the wet. And then this delayed signal goes straight to reverb. And let's say, if we wanted to bypass the reverb, for example, we can say delay group.set out 0. And I'm going to try to run this while it's playing. That work? Delay. It's not called right. It's not called that. There we go. Right. I misspelled my group name. It's delay_grp. So we've set the output of the delay group to be 0, which means it's going straight to hardware. The reverb synth is still hanging out here, but it's been cut out of the signal chain. and now it's back in. It's probably, maybe a little frustrating at first when you just can't really see any patch cables, right? Like, how are these things connected? It's just a bunch of rectangles. And so it does take a little bit of visualization. And there really isn't, as far as I know, some tool which will let you visualize the interconnectedness of your node tree. But I think with a little bit of practice and just kind of tinkering, experimenting, and making sure you really understand all this, should be fairly straightforward. All right, so anyway, that's it. I'm gonna call it here, and more homework for all of my students on Thursday. Some in-class take-home problems, focusing on server architecture, synths, groups, nodes, buses, in, out, order of execution. And I think we're gonna do this same time next week. Gotta look up the topic. It might be MIDI. I'll have to check the syllabus, but it might be something else. But it'll be something new. And right. Anyway, I hope this was useful. Hope this was interesting. And thanks everybody for watching. Same time next week. See you then.